right, lesson 7b, rational functions and their properties. It says, use the equation for f of x and graph the function to analyze completely. So example 5, it wants us to factor and simplify, and then we're going to find a bunch of information here about it. All right, so let's go ahead and factor the numerator. The numerator is just our x box. We're looking for two numbers that are going to multiply to negative 9 that are going to combine to be negative 8. And so that is negative 9 and positive 1. So we have 3x minus 9 times 3x plus 1. But remember, if you can simplify within each factor, you need to do so. These are both divisible by 3, so it's really x minus 3 times 3x plus 1 over, and then we got our denominator, which is just a difference of squares, so it's x plus 3, x minus 3. All right, so let's go through and analyze this. So I'm going to jump to where it says domain. So the first thing we're going to do is look at domain, and it is a fraction. So we know that for a fraction, remember that that denominator cannot equal 0. So x squared minus 9 cannot equal 0, or we know already that that's x plus 3 times x minus 3 that can't equal 0. So set each factor not equal to 0 and solve. So subtract the 3, so x cannot equal negative 3. Add this other 3, x cannot equal positive 3. And so I know if I use a number line, x cannot equal negative 3 or positive 3, which means those are going to be open circles. But it can be everything else. It's everything to the left of the negative 3, in between negative and positive 3, and to the right of the positive 3. Now I did forget to put my infinities on here. But so we can see our intervals. So there are the 3 intervals in our domain. So I know that my domain is from negative infinity to negative 3, union, negative 3 to positive 3, union, 3 to infinity. Okay, and we can see that in our graph as well. If you look at our graph keeps going to the left, and it's going to go right here where I'm drawing. You can see it's going to get super close to that vertical asymptote there, which is at that negative 3. And then it's going to jump over that negative 3 and come down here. So that's where that first interval stops and the second interval starts. So from that negative 3, we're going on until we hit that hole right there, which is at the x value of positive 3. So that's that second interval. And then we jump over that hole, and from that positive 3, we keep going to the right to positive infinity. And that would be that third interval. All right, so we can see it in our graph as well. All right. Then when we talk about the hole, the asymptote, we're just going to talk about the range. So for the range, I'm going to go ahead and use my graph to kind of guide me on this one for now. So for the range, we can see that our graph does keep going down. Our graph does keep going up, but we got some funny stuff. One thing, we got that hole right there, which has a y value of, I don't know, maybe 1 point. I'll tell you what. Actually, let's go find that hole first. That way we're not guesstimating it, actually. That's a good idea. Sorry about that. All right, so let's go find that hole. So remember, in order to find the hole and the vertical asymptote and the x-intercept, we want to find the zeros of the numerator and the denominator. That was not what I meant to hit. Turn my pen on. All right, so let's go find those zeros of the numerator and the denominator. So my numerator, I'm going to set that x minus 3 equal to 0 and the 3x plus 1 equal to 0. So that's going to give me x is equal to 3 and x equals, subtract the 1, divide by 3, so negative 1/3. For the denominator, we're going to set the x plus 3 equal to 0 and the x minus 3 equal to 0. All right, so subtract the 3, we get x equals negative 3. Add the 3, we get x equals positive 3. I'll draw a little line there. All right, so remember, your holes are what they have in common, the common zeros in the numerator and the denominator. So we can see that both of these have an x equals positive 3. So that means we're going to have a hole at 3 comma something. Now how do we find that y value? Well, remember, let's go ahead now, let's go back to our factored function and let's go ahead and cancel out what we don't need, or what's on top and bottom, because we don't need that in there. So that's that x minus 3. That's where the 3 of the whole came from. So we were left with 3x plus 1 over x plus 3. Now we're going to take that x value and we're going to plug it in there. So that's going to give me 3 times 3 plus 1 over 3 plus 3. So 9 plus 1 over 6. 10 over 6, we always reduce our fractions, so 5 over 3. All right, so remember your vertical asymptote is the factors that only the zeros that only the denominator had. So the denominator, the only zero that it has is that negative 3. So we have a vertical asymptote at x equals negative 3. Now the horizontal asymptote, we looked at the highest degree of x and we decided where it was at. So I'm going to go back to the original one, because you can use original or you can use your factored down one. It doesn't matter. So I'm going to go back to my original, and I see that my highest degree is both. And so remember, if it's both, it's a ratio of its coefficients. So 3 on top, 1 on bottom. So it's going to be y equals 3 over 1, which is 3. And we can see that in our graph here. We can see that horizontal asymptote right there at y equals 3. And we can see that hole right there at 3 comma 5/3. So when I go to do my range now, I can see my graph keeps going down to the bottom. So I know it's going to go to negative infinity. And it's going to come up. Let me start drawing it. So we're coming up, and it keeps going up until we get to the y value of that hole, which is at 5/3. Union. And then we're going to jump over that hole. So we're going to go from that 5/3 all the way to that horizontal asymptote. So 5/3 all the way to the horizontal asymptote, which we said is at 3. Union, and at 3 it jumps us back over here. We're going to keep going up from 3 to positive infinity. All right, and then it asked us some questions here. So it gave us a graph so we can see it again. It wants the limit as x goes to negative infinity. So as my x is going to negative infinity, so I'm going to the left of my graph, what's happening to those y values? They're getting really close to that horizontal asymptote, which was at 3. As x goes, the next one across says limit as x approaches positive infinity. So as my x is getting bigger, we're going to the the right. What's happening to my y values? They're also getting close to that horizontal asymptote, so they're getting close to 3. All right, the next row there says the limit as x approaches 3 from the left. So now from the left side of my graph, we're going to go towards the 3. So if I start over here, I'm going towards 3. Now this is negative 3, okay? After we go so far, it's going to drop me down and start up here. So we're still going to go towards the 3 right here. Our y values are going towards the y value of that hole, which was, you know what? I'm doing the wrong one. All right, I'm sorry. I jumped to this one. I did positive 3, so I'm down here. Okay. I was doing positive 3, so I'm sorry. I apologize. Anyways, so as I'm going towards that hole there at 3, from the left, I'm going to that y value of that hole, which was 5/3. And then as I approach that 3 from the right, so as I come from the right side of my graph towards that hole, I'm approaching that y value that's 5/3. Now, the one in the middle, the one I misread, says if we're approaching negative 3. So as I'm approaching negative 3 from the left, So I'm going to come from the left of my graph. I'm going to go towards -3 here. Notice my y values are shooting upwards. So they're going to keep going up till we hit infinity. And then as I approach -3 from the right, so here, even though I have to jump over that hole, I'm still going towards -3 from the right. My y's are going down, and they're going to go down to negative infinity. All right, so given the function g of x, use a calculator to complete the table. So total g of x is equal to x squared minus x minus 12 over x squared minus 2x minus 8. And so I'm going to type that into my y equals, and I'm going to go to second, the calc button, which is your trace. And if you look at number 1, it says value. So I can just ask it x values. We may have to adjust our window a little bit, or we can go to our table and look, whichever. All right, so when I go in and I look at x is negative 500, I get 0.998. When x is negative 100, I get 0.900. When x is negative 2.001, I get negative 999. At negative 2, it tells me it's undefined. It says error. Negative 1.999, it tells me 1.001. At 0, it says 1.5. 3.999 says 1.167. 4 says undefined. 4.001 says 1.167. 100 says 1.010, and 500 says 1.002. All right, so using those numbers, it says as x approaches negative 500, g of x is approaching what? So look at your numbers here. So as we're going towards negative 500, my y values are getting closer to what number? Well, at the negative 2.001, we were really small, and then these two are really close to each other, and both of them are really close to the number 1. So we're approaching 1 there. And as x approaches positive 500, so now from the other side, g of x is approaching what number? Well, notice again, we're 1.167. We're at 1.010, 1.002. We're also approaching 1. So what can you conclude about the end behavior of the graph of g of x as the x values go very large or very small? So what's happening here, as we go in both directions, when my x values are getting really small on the negative side or really big on the positive side, our y value is going towards 1. And so since the y value is going towards 1, that means that that is our horizontal asymptote. So y equals 1 is a horizontal asymptote. All right, as x approaches negative 2 from the left. So let me erase some of my little extra lines I drew in here. I'm going to have to make that eraser smaller. All right, so as I'm approaching negative 2 from the left, so from this side, what do you notice is happening to those y values? Well, they're at they're at 0.998, 0.900, negative 999. All of a sudden, they were holding like this, and then they drop. So what's happening is those y values are going to go down, and they're going to keep going down until we hit negative infinity. And then as we approach negative 2 from the right side here, we can see that so at 3.999, we had 1.167, 1.5, and then we're going to 1.01. I'm sorry, that's 1001. I miswrote that. I apologize. Can't read my own handwriting here. All right, so I see what's happening is that these first two, the 3.999 and the 0 are really close, but then that negative 1.999, my graph is going to jump up. So therefore, we're going to go up into a positive infinity. I am so sorry about that. All right, sorry about that. So what we were saying there is as x approaches -2 from the right, our y values are going to go up, so they're going to go up to positive infinity. It says, what can you conclude about the behavior of the graph of g of x as x approaches -2? So because one side is going down to negative infinity, the other side's going up to positive infinity, we know then that x equals -2 is going to be a vertical asymptote. All right, now, so that I can still see that table, I'm going to stay on this page, and I'm just going to kind of redo them. So you're just moving down your page here. So let me see what I can do. Let me erase what I wrote on these. I'm just going to write in the next ones. All right, so C says as x approaches 4 from the left, g of x is going to approach what? So let's look at that. Let me come up here and get rid of some of these extra things again. All right, so as we approach 4 from the left, so that's going to be from this side. Notice we're at 1001, we're at 1.5, we're at 1.167. Okay, so that was a little iffy. Let's look at the other side. So as x is approaching -2 from the, as x is approaching 4 from the right, what's happening to our g of x? Well, as I approach 4 from the right, I notice that it's 1.102, 1.101, 1.167. They're approaching the same number here, which means in between there is going to be a hole. Now, we don't know exactly where that hole is, but both of those would round to 1.2. So I'm just going to use 1.2. We can find it, though, algebraically. All right, and so let's actually do that. So let's find where that hole is. So remember, the hole is going to be the zeros that it has in common in the numerator and the denominator. So let's stop and let's actually factor this out so we can tell what that number exactly is. All right, so I'm going to x box the numerator, and I get x minus 4, x plus 3. I'm going to x box the denominator. I get x minus 4, x plus 2. So the zeros of my numerator, so I'm going to set both of the numerators equal to 0. And so I get x equals 4 and x equals -3. Zeros of the denominator will give me x equals 4 and x equals -2. So remember, the holes are what they have in common. So we can see that both of them have the 4. So that told us we have a hole at 4. And then remember, to find out the y value, you plug the 4 into your remaining factors. So these two would cancel. And so this is what I would plug the 4 into. So 4 plus 3 over 4 plus 2, which is 7 over 6. And so to be technical, these would actually be approaching 7 over 6. All right, and so then it says, what can you conclude about the behavior of the graph as g of x approaches 4? We know that there is a hole at 4,76 is what we can conclude. All right, moving on. D says, what do you know about g of 0 and explain? Well, g of 0, I can plug 0 into my function. And so it doesn't matter if I use original or the shortened one or the factored out one, because I'll get the same answer in the end. So remember, this just means x is 0, so we're going to plug in 0. Okay, the zeros will all cancel. So on top I have negative 12. On bottom I have negative 8, which reduces to positive 3/2. And so we know then that when x is 0, y is 3/2, which that is our y-intercept. Remember, when x is 0, that's when we have our y-intercept. All right, so let me erase a little bit here again so I can still see what I need to. So for E, E says find the real zeros of the function by simplifying the expression. So the real zeros, remember those are the zeros that are unique to the numerator. So we know that our 0 is at x equals negative 3. So x equals negative 3 is a real 0. All right, and then E. So E says, how am I off? This was E, sorry. So I'm on F. That's what happens when I didn't label it. All right, F says, using the table and your results from part E, state the intervals where g of x is greater than 0 and where g of x will be less than 0. So let's kind of talk about what we already know. So I'm going to do a quick little graph. Okay, we said that there's a 0 at negative 3. Just using E. D says there's a y-intercept at 0, 1/2. I'm sorry, 3/2, so that's 1.5. So right there. Working my way back up. C says there is a hole at 4 7/6. So x is 4. And y is just a little bit above the 1. Now remember, hole is just going to be an open circle. We said there is a vertical asymptote at negative 2. And there is a horizontal asymptote at 1. All right, and so we know that as looking at my table here, as we're going towards that negative 2, our y values are going to get smaller. So they're kind of doing like this. Between the negative 2 going towards the 4, I'm going to draw going towards that that vertical asymptote. So from the 4 going towards the negative 2, my y's are getting bigger, but I have to go through that y-intercept. And then I can see to the right of the 4 here, they're just kind of going towards that horizontal asymptote. So even though it looks like it's flat, it's really not right there, okay? All right, so we want to know the intervals where g of x is greater than 0 and where g of x is less than 0. So g of x is greater than 0. So that's where it's above the x-axis. So I can see right over here. So from negative infinity. So negative infinity to that x-intercept, which is at negative 3, parenthesis, because it just says greater than. And then I can see that it's greater than all of this, but you got to be careful because of that hole. That domain is split. So we got from the vertical asymptote to the hole, and then from the hole to infinity, okay? So union negative 3 to the hole at 4, union 4 to infinity. And then we're looking for where g of x is less than 0. Well, the only place g of x is below the x-axis is between that x-intercept and that vertical asymptote. So we're going to say from the the x-intercept at negative 3 to the vertical asymptote, which was at negative 2. You know what? I messed up right here. Anybody catch that? That was supposed to be that vertical asymptote where it started, and I put the x-intercept. That should have been negative 2. Hopefully you caught that. I don't know what I just did. All right. All right, so analyzing a rational function with a whole. So the factored form of a polynomial rational function readily provides information about the real zeros. It can reveal information about x-intercepts, asymptotes, wholes, domain, and range. So we can use a simple process below. Factor the numerator and the denominator of r and find the domain. Write the rational function in the lowest terms. Find the asymptotes and the wholes. Find the intercepts, and then determine the end behavior of the function. So let's try this. It wants us to analyze and graph this function. All right, so the first thing it said to do was to factor it. So let's go through. We're going to X box the top. So I need two numbers. Going to multiply to 6, combine to negative 7. So that's going to give me 2x minus 6 and 2x minus 1. Simplify that first one, so it's x minus 3 times 2x minus 1. Over, factor the denominator, that's just your difference of squares. All right, then go and find the domain. So remember domain. I'm going to do this here. All right, so your domain, it's a fraction, so we know that the denominator cannot equal 0. And so I'm going to use that factored form. So x plus 3 times x minus 3 cannot equal 0. So x plus 3 cannot equal 0. X minus 3 cannot equal 0. So x cannot equal negative 3, and x cannot equal positive 3. So our domain is going to start over at negative infinity. It's going to go to the smaller one of them. Union from the smaller number to the next smallest number. Union, and since 3 was our biggest number, the biggest number to positive infinity. Remember, I've been doing it with the number line, so if you need the number line, do it. There's nothing wrong with that. All right, then 2 is to simplify the rational function. So we have that r of x is equal to, the x minus 3's will cancel, so it's 2x minus 1 over x plus 3. Three told us to find the wholes, the asymptote, and the asymptotes. Okay, so now those wholes are those factors that we just canceled out. So remember, in order to find these, it had told us initially to just use the zeros of the numerator and the denominator. So I'm going to go back real quick, and I'm going to go find my zeros of the numerator. So I'm going to use what we canceled out, because we don't cancel usually until afterwards. So x minus 3 equals 0, 2x minus 1 equals 0. So we get x is 3. Here we're going to add the 1 and divide by the 2, so x is 1/2. I'm going to do the same thing for the denominator. X plus 3 equals 0, x minus 3 equals 0. So x equals negative 3, and x equals 3. So then remember, your wholes are unique. Your wholes are what the numerator and the zeros, the numerator and the denominator have in common. And so we can see they both have a positive 3. So that's going to be our whole at 3 comma some number. And we just plug that into our simplified rational function. So that 2x minus 1 over the x plus 3. And we got 5 over 6. So there's the ordered pair of our whole. All right, then our vertical asymptote remember, is the zeros that are unique to the denominator. So unique to the denominator is just that -3. So x equals -3. And then it wanted horizontal asymptote. And so for the horizontal asymptote, we look for that highest degree. Is it top, bottom, or both? And so I'm just going to look at the original. I can see the degree is 2 on top, 2 on bottom. So I know it's going to be a ratio of the coefficient, which is 2 over 1. And 2 over 1 is 2. Then it told us to find the x and y intercepts. Was the step 4 it gave us. So the x-intercept, remember, is the numbers, or the zeros that are unique in the numerator. So the one that's unique in the numerator was that 1/2. So we could say it's at 1/2 comma 0. And then we have our y-intercept. Our y-intercept is just when we plug in 0 for x. And so we can use the original or we can use the reduced form. It doesn't matter. I'll use the reduced one. So the 2 times 0, let me move that down a little bit. So 2x minus 1 over x plus 3. So that's -1 over 3. So it's 0 comma -1/3. All right, and we've got enough there to start doing our graph. So let's see, we know we have a hole at 3 and 5.6. So I'm not 5.6, 5 over 6, sorry, which is almost at 1. So like right in there. So just draw you an open circle. We have a vertical asymptote at -3. Remember, we're going to draw them dashed. All right, we have a horizontal asymptote at y equals 2, so draw that dashed. We have an x-intercept at 1/2. And we have a y-intercept at -1/3. All right, now this part of the graph, we can kind of see what's going on, okay? If we play connect the dot and let the asymptote shape us, we can see it's going to do something like this here. And then this is going to have to go towards that horizontal asymptote. But we don't know what's happening on the other side. So the other side is either going to look something like this or it's going to look something like that. How do we know which? Well, look at the last one that I just drew there. If it's going to do something like this, it's got to have an x-intercept somewhere over here. Do we have an x-intercept? We don't. So therefore, I know that my graph is going to be somewhere up in here. We don't know exactly where yet. We could pick some ordered pairs. We could pick some x values and plug them in and find those y values to help us. But for right now, we're okay saying we know it's going to be up there. All right. And that moves us on to using the differences to determine degrees. Well, that's the wrong thing. Hold on. Looking at my notes. I found my missing notes. That's why. It's in the wrong section. All right, guys, that is the end of lesson 7.